second portion of section 1.3 talks about factoring, and if you recall, there are two steps in factoring. Step number 1, you factor the greatest common factor. Step number 2, you count the number of terms. If you see two terms, it's one of these three formulas. If you see four terms, you would use grouping. And if you see three terms, there are 5 different ways you could factor, any method that you learned in your algebra class. So I'm looking at the first problem, which says factor completely. I'm glancing at this. So the first order of business, do I see anything common in all of those? I see an x. That's step number 1. You factor that out. You're left with 3x cubed plus x minus 5. And this is not quadratic, indicating you are done. And if I look at the next, again, the first order of business, I notice 5 is common in all of those. X cubed, x squared, and an x, you factor out the variable with the least power, y to the fourth, y and y cubed. So divide those. 15 divided by 5 is 3x squared y cubed, negative 5x, and a positive 9y squared. And again, this is not quadratic, indicating you are done. And if I look at the last, I notice there are two terms. X minus 5 is common in both. If I factor that out of the first, when I divide those, I'm left with an x. And when I take the second term divided by this, I will be left with a negative 3. And there it is. So, okay. Next problem up, I look for greatest common factors. I don't find any, so I group them. To be able to really nail this, you want this in descending order. So if I factor an x squared out of those, I'll have a 2x plus 3. And we take this sign 95% of the time. What's common, greatest common factor between 4x and 6 at 2? Negative 4x divided by negative 2 is a positive 2x, and a negative 6 divided by negative 2 is a positive 3. And we're back to this step. We factor out a 2x plus 3. What we have left, out of this term an x squared, and out of this term a negative 2. So at this stage we're done, because even though this is a perfect square, this is not. So I can't apply that. In theory I can, but for our class, for now, we say we can't, and that's that. And if I look at these two problems again, I see 4 terms, anything common in both, all well, 12, 9, 8, and 6. Nope, this is 3 times 3. This is 2 times 2 times 2. And it seems this doesn't have an x and this doesn't have a y. So greatest common factor, there isn't. You group them. You take the first two and the last two. 90% of the time this works. Otherwise, you might have to take the first and the third, the second and the last, that will. So what's common between those? I noticed that 3x is common between both of those. 12x squared divided by 3x is 4x, plus 9xy divided by 3x is 3y. You take that sign 95% of the time. 2 is common in both of those. Negative 8x divided by negative 2 is 4x. And negative 6y divided by negative 2 is a positive 3y. And again, this is common in both. You factor that out. So if it's 4 terms, you're going to use greatest common factor twice. Now if I take this term divided by this, I'll have a 3x, and out of the second term, I'll have a minus 2. And factoring is transforming addition and subtraction into multiplication. So if you factor and your final result is added or subtracted, you really didn't factor. Factoring is transforming addition into multiplication or division. Same deal here. I noticed that there's nothing common in all of those. So step 1 is done. Step 2, 4 terms, grouping. What's common between those and a squared? There'll be a 7a minus 3. You take that sign 90% of the time. What's common between 49 and 21? A 7. So 49 divided by 7 is 7a minus 3. And again, this is common. You factor that out. And what's left out of the first is an a squared and a 7 out of the second. You're done because there is no formula for the sum of squares. This is a square, this is not, and that's a plus. So we only have a formula for two squares with a minus in between. Oh, okay, this one's different. There we go. So when I get to three terms, again, there are so many ways you could do that. The way I do this, we take the factors of the first, the factors of the second, add up to give me a 3. 1 plus 2 is 3. Perfect. To get a 3, there's a positive 2 and a positive 1. I need them both to be positive to add up to 3. So the sign carries over. I put those in one parentheses and those in one parentheses. The first has a variable. I split that in the first. The last doesn't. I'm done. Again, this technique I learned. I'll be more than happy to show you that. If you come to class or during office hours, I could elaborate on that a bit, but it's not something I could do in a few minutes. So whatever you learned, there's the Berry method. There are so many ways you could do this here, one-on-one. Closest factors of 6 are 3 and 2. I need them to subtract to get me a 5. 2 minus 3 is 1. That doesn't work. The next factors of 6 are 6 and 1. 1 minus 6 is 5. That works. That's a 1. That's a 6. To get a positive 5, you must get a positive 6 and a negative 1. The sign carries over. So the 1 and the positive 6 in one parenthesis, the 1 and the negative 1 in another parenthesis. The first has a variable. I split that in the first. The last doesn't have a variable. I'm done. And if I look at this problem, first step of factoring is taking the greatest common factor out. 2 is common in all of those. I factor that out. Then I see 3 terms. Well, 1 and 1. Closest factors of 20 are 4 and 5. I need them to add. So if it's a plus, you add. If it's a minus, you subtract. Add to get the 12. 5 plus 4 is 9. That doesn't work. So I try for something else. What are the next closest factors? Well, 2 and 10. 10 plus 2 is 12. That's perfect. This gives me a 10. This is a 2. I want a negative 12. To get a negative 12, I need both of those to be negative. So the 1 and the negative 2. The 1 and the negative 10. And it doesn't matter which one you write first. The first has a variable. I split that in the first. Don't forget to copy that too. And I have just factored that problem completely. So that's how we factor. 2 steps. Step number 1, look for greatest common factor. Step number 2, check whether you have 2 terms, 3 terms, or 4 terms. If it doesn't match any of those, we say prime, meaning we can't factor it. At least not yet. In this class, we're going to learn how to factor anything, but that's in chapter 3. When I get to the next problem, the same deal. I say, okay, well, let's see. I notice 3 is common in all, and they both all have an a. So that's 3a squared minus 8a plus 5. Well, 3 terms, it's quadratic. Factors of 3 are 3 and 1. Now that when this is 1 and 1, I don't have to do much work. I just list those as I see fit. When this is not 1 and 1, when I list the factors of 5, I would list those both ways. So I'm undoing foiling. That's the idea. I need the factors to add to get me an 8. 15 plus 1 is 16. That doesn't work. 3 plus 5 is 8. Perfect. That's a 5, that's a 3. To get a negative 8, I need both of those to be negative. So the 3 and the negative 5, the 1 and the negative 1, I'm sorry, 1 and the negative 1, correct. The first has a variable, you split that in the first. Don't forget to copy the 3a down, and I just factored that problem completely. Next problem up. Greatest common factor. Well, I know 5 goes in all of those, and nope, x, I was going to say x, this doesn't have an x, that's it. This is 40 divided by 5 is 8x squared minus 5 divides 70, what is that, 14 times? Yeah, correct. And 3y squared, not to worry. This is quadratic in x and quadratic in y. So, closest factors of 8 are 4 and 2. The fact that this is not 1 and 1, I have to list that twice. I need them to add to get me 14. 4 plus 6 is 10, that doesn't work. 12 plus 2 is 14. There's a 12, there's a 2, and I want a negative 14 out of those. Well, the only way to get that if they're both negative. So, the 5 I'm going to copy down. The signs carry over. Always, as you see, 4 and negative 1, 2 and negative 3. The first has an x, I split that in the first. The last has a variable, I split that in the last. You could do that as long as you have a quadratic, in case you've forgotten. Quadratic means you start with a square, linear, and constant. As far as x is concerned, x squared, x, no x. As far as y is concerned, no y, y and y squared. So this is quadratic in both. And if I look at the last problem, well, 7 times 7, nope, nothing matches. Well, alright. What are the closest factors of 49? 7. Closest factors of 9 is 3 and 3. I need them to add to get me 42. 21 plus 21 is 42. And I want a negative, so in this case a minus. If this was a positive, then you just put a positive. Doesn't matter. I'm going to make it a positive just for the heck of it. So this will be a positive. Otherwise they're both negative. So 7 and a 3. 7 and a 3. The first has a variable, I split that in the first. That's a fine answer. Or, most likely, the book will write as 7x plus 3 squared. If it was a minus, that would have been a minus. The process is identical. So, a few more to go. In this case, I'm looking at continuing on. Well, factors 2 and 1. Closest factors of 3 are 3 and 2, 2 and 3. I need them to subtract to get me 11. 4 minus 3 is 1, that doesn't work. 6 minus 2 is 4, that doesn't work. The other factors are 1 and 6, 6 and 1. So 12 minus 1, that works. So there it is, I found them, 1 and 6. 12 minus 1 gives me 11. I want positive 11. So 12 must be positive and 1 must be negative. The sign carries over. And we know the drill. This is going to be 2z minus 1 and a z plus 6. Or 1z if you want. It's the same thing. Alright, and the next problem on the list. Closest factors of 4 are 2 and 2. 2 and 2. You want them to add up to give you 3. 4 plus 4 is 8. That doesn't work. So what if I go for 1 and 4, 4 and 1? 8 plus 1 is 9. 8 plus 1 is 9. Actually, it turns out there are no factors of 4 and 4 that add up to 3. Not possible. So we say this is prime. Prime meaning we can't factor it any further. So those are the worst because you have to take into account all different combinations. I look at 3 terms and what do I notice? If this is a square, I'm aiming for that formula. Let me see if I can copy that down. Okay, let's see if I could squish that down there somewhere because that's what we're going to use. And I'm going to shrink that. Oops, barely see it. Okay, a bit bigger, maybe 14, 16. Okay, and I'll start this in the next video and wrap this up. So if I keep this in front of me,